All right, let's get into the example. I hope you were able to watch and listen to a bunch of the examples earlier so that this is just the confirmation that you do in fact understand and know what you're doing and you are as amazing as you feel. Let's go. We are solving a polynomial equation. Everybody knows the absolute best way to get all of your solutions is to get your polynomial equation equal to 0 first. So we're going to add 343 to both sides. 6x to the 6x, listen to me. 64x to the third plus 343 is equal to 0. If you want some kind of like insurance that you're doing things correctly, one thing is to always remember when you're finding all solutions that it includes the real and the imaginary, and that in total, considering multiplicity, because multiplicity of 2 would mean that answer counts twice. Multiplicity of 3 means that answer counts 3 times, okay? You're going to have the same number of solutions as the largest degree in your, or degree of your equation, in this case 3. Irrational or imaginary solutions will also come in pairs. So since we have 3, it's possible we have 3 real solutions, but it's also possible we have 1 real and 2 imaginary, okay? Or all 3 real such that 2 are irrational, something like that. Give that some thought, but that's a good way to look at it as like an insurance that you are doing it correctly. You're checking as you go and you're confirming before you submit it that it makes sense, okay? It's just like a little backup before, just throwing it and submitting it and being like, I hope I'm okay. Now, we also have a sum or difference of cubes example yet again. In this case, it's a sum, right? If you need to go over how to factor these, you are going to have to do that on the playlist of the factoring methods. Factoring method number 3, sum and difference of cubes. So here we are going to recognize what exactly is being cubed. We should know our perfect cubes by heart. So we should definitely know that this is 4x to the third power, and we should know that this is 7. When we factor a sum or a difference of cubes set up in this way, we will have a linear binomial and a quadratic trinomial, prime quadratic trinomial. Our linear binomial is going to be 4x plus 7, and our prime quadratic trinomial will be 16x to the second minus 28x plus 49. Now these numbers, 16, 28, 49, not great. And I'm going to do the quadratic formula with my little trick again. And I even have a super trick, which I'm going to save for another video because I don't know if we're ready yet. I just don't. Let's keep moving. Zero product property. We can take the linear factor. It's prime. It's done. And we can solve. Show the work if you are not a math teacher. For x is negative 7. Divide by 4. X equals negative 7/4. Fractions are your friends. So we can leave that as is. Now we have our prime quadratic. Prime means it will not factor. There are no factors, like 3 is prime, 2 is prime, 5 is prime, right? Nothing multiplies nicely to give us that factor or product or piece of whatever it is we're trying to break down, right? So we're going to use our quadratic formula. Yes, I know. I'm writing it down again. Why? Not for myself, for you guys. I think that if you are feeling any degree of confidence that you should go ahead, press pause, try this all the way on your own and see what you can get up to, and then just press play in little snippets along the way, only as you need me. You've got to do it by yourself. Do not sing with the track. Make sure you're learning to do this a cappella, okay? And if you can, that's another form of insurance that you know you are confident that you are capable of doing this. So on a test or a quiz, you could kind of leave your anxiety and stress at the door. All right, all over to A. Okay. X equals negative B will become positive 28 plus minus the square root of negative 28 squared minus 4 times 16A times c, which is 49, all over 2 times a, which is 2 times 16. Okay, I'm using my little trick. So let's like scooch this all the way around, shall we? All right, there we go. X equals 28 plus minus the square root. If you need this explained, you have to go watch one of the other examples where I did this, all right? I think it was the previous 2 examples. 28 is 7 times 4, which is 2 for the 4 and 7, but we have it squared. The negative doesn't matter. 2 and 7, but that's another 2 and 7. So really, this is 28 squared. I don't even need to actually square 28. Who wants to? Not me, not you. We don't want to do that. Minus 4, 2. A, 16 is 4 squared, but it's also 2 to the 4, right? So that's another 1, 2, 3, 4, and then 49, 7 and 7. I haven't multiplied any of this yuckiness, right? All over. Oh, what am I doing with this line? It should go all the way here. Silly. 2 times 16, 32. Press pause if you think you can do this next part on your own. Be brave. What do they have in common? 1, 2, 3, 4. 4 2s and 2 7s. 1, 2, 3, 4 2s and 2 7s. What's going to be left if I factor it out? A 1 and 2 times 2, 4. Let's keep it moving. X equals, please ignore him. Oh my gosh. He like knows I'm recording and I'm talking, but not to him. I don't know what his deal is. If you can't even hear him and you think I'm just talking crazy, then I'm also sorry about that. I'm not crazy, but my dog is crazy. 2 2 2, 7 7. What's left? 1 minus 4. It's always 1 minus 4. It's always a negative 3 when we're dealing with the quadratic from a sum or difference of 2 cubes. Now, takes a pair to make a square. These can all come out. X equals 28 plus minus 2 times 7, square root of negative 3. That negative comes on out. Imaginary unit I all over 32. X is equal to 28 plus minus 4 times 7 is 28. I root 3 all over 32. Home stretch. We're almost done. All we need to do is access the purple pretzel. Is there something I can reduce? And they're both even. Well, both. By both, I mean 28 and 32, but all of them are even. But bigger than that, they're all divisible by 4. If you only did the 2 at first, you would have gotten 14s and 16s. You could do another 2, or you could just do the 4 right away. Right? Right. X equals, so what did we just say? Divide everyone by 4. 7 plus minus 7i. 3 all over 4 times what is 32? Please learn your times tables. Please don't touch your calculator. Please don't. Okay, please. 8. And there you have it. Those are your 2 imaginary solutions. We got 3 altogether. Third power, right? And here's our 1 real. 2 imaginary. Oh boy, that's not helpful. There we go. 1 real. 2 imaginary. Okay? I hope you're getting these right. I hope you feel so smart right now. You are. You can do this. Stop reaching for the calculator, okay? That's like going to the gym and having the person spotting you do all the lifting of the machines. Like, you're not getting anything out of it if, like, your strong friend's just doing it for you, you know? So, go to the playlist if you want to see more examples. Click the click through if you need whatever's there. I'll try to even link those factoring videos somewhere if you need help with that, depending who you are, where you are. And I hope you have a great night or day or weekend, whatever. I don't know when you're watching this. Adios.